In this section, we're going to talk about performing arithmetic operations with something called complex number. Complex number is just basically a number that has something called a real part and an imaginary part. So all this time we've been working with the real number set since you guys were little, and now we're going to actually combine it with something called imaginary numbers. So this form a plus bi is what we know as standard form of a complex number. And all it is that the first number that usually comes in this form or in this binomial is usually what we call the real number part. And that actually represents a number from the real number set. The second one is what we call imaginary number. And an imaginary number, again, we'll define that in a little bit, but we can graph this on something called a complex number plane, where the x-axis now is going to represent a real number part, and the y-axis is going to actually act as an imaginary axis. So for example, if we take a look at example number 4 on the back of your worksheet, this is a typical question you might see. Plot the complex number. So if we go ahead and take this 4 plus 3i, all we're really doing is starting from the middle of the axis here, and we're going to actually count 4 spaces on the real number axis, which is actually right here. So again, if we go ahead and count here, we'll go ahead and go 1, 2, 3, 4, and that actually represents the 4. Then from here, we're actually going to go 3 spaces up. So since this part is the imaginary axis here, we're going to go from here 1, 2, 3 spaces up. And if you can see, that actually gives you the point 4 plus 3i. Now looking at b, negative 5 minus 4, that means all we're going to do is go ahead and go 1, 2, 3, 4, 5 to the left, and then from there we're going to go ahead and go down 4 spaces. So from here we're going to go down 1, 2, 3, 4, and that will represent the point negative 5 minus 4i. So what is an imaginary number? Well, an imaginary number or a unit is identified as the square root of negative 1. Whenever we see basically a negative inside the square root, we actually rewrite it with just the italic letter I. So looking at the way this actually works, if I look at the I to the first power, this is technically square root of negative 1, but we just leave it as I. If I have I squared, well, if that means I'll take square root of negative 1 times square root of negative 1, but if you notice, if we go ahead and combine that, we have negative 1 squared with the square root. We know that the square root and the squared cancels out, so this is equal to negative 1. If I have I to the third, again, we can write it as I squared times I to the first. Now knowing that I squared is negative 1, and knowing that I is just I, this actually equals to negative I. And if I say I to the fourth and I ask what this actually means, again, this really, we can write it as I squared times I squared. We know that I squared is negative 1, so negative 1 times negative 1 equals to 1. So if I go ahead and actually list out all the factors of I, if I actually, not factors, but multiply all the i's, there happens to actually come up with a pattern. So again, I is I squared is negative 1, I to the third is negative I, and if we keep going, we notice that every fourth one, in this case here, we notice that it always equal to a 1. And that's very helpful when it comes to simplifying imaginary numbers, because we don't like to have any power higher than a 1 when we have imaginary numbers, because as you can see, they always can be simplified. The other important fact would be the I squared, which equals to negative 1. This comes in really handy when we actually have to multiply binomials. So another way to actually remember this is actually looking at the axis itself. So again, the y-axis is the imaginary axis, the x-axis is the real axis. If we go ahead and start on the imaginary axis and we go 1 unit up from the middle, that is just I. And if we go counterclockwise on the real axis, that's negative 1. Then you have negative I, and then you have 1. If you notice, if we start all over again, this would be I to the fourth or I. This would be I to the fifth or negative I. Then you have negative I. which is going to be I to the I to the 7th, and then this one here is going to be 1 for I to the 8th, and so forth. So again, we just go in order. So this is I to the 2nd, I to the 3rd, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th, and so on. So when it comes to actually adding and subtracting imaginary numbers, it actually acts just like if you were adding like terms. So here's an example. It says here you want to write as a complex number in standard form. And again, remember, standard form is where the real part comes first and the imaginary part comes second. So in this case here, we have to realize that this is just asking us to subtract because there is a minus sign in between. So looking at this, the first thing, let's rewrite the first part without the parentheses because it's not necessary to have it. But the second part, we have to realize that we need to distribute the negative sign. So negative times 4 is negative 4. Negative I times negative is going to give you a positive I. And then from here, it's just a matter of combining like terms. Since the 6 and negative 4 are like terms, we can write that as just negative 2. And 3I and I is going to become a positive 4I. So that's a problem that you may simplify in that fashion. So here's another example. Again, it's off your worksheet. Again, this one has a plus sign in between. So if I understand that part, then all I'm really doing is dropping all the parentheses. And at this point, I'm just adding like terms. So again, the 2 and the 7 are like terms. So that's 9. And then the 5I and the 2I are actually like terms. So we're just going to, a negative 2I. So we're going to put that together and we get 9 plus 3I. Now here's a problem where you're multiplying two binomials. So we just basically have to follow the rules of distributed property, or most people know it as FOIL. So if I go ahead and do this, we're going to go ahead and take 2 times negative 5, which is negative 10, and then we're going to take 2 times 2i, which is 4i. Then we're going to take I times negative 5, which is negative 5i, and then I times 2i, which is 2i squared. But with this one, we have to understand that we never can actually have any power or a degree higher than 1. So this one actually has I squared. So this one can be simplified to 2 times negative 1. So if we go ahead and simplify everything, we get negative 10 plus 4i minus 5i minus 2. And again, at this point, we're just combining like terms. So in this case, the negative 10 and negative 2 can go together. The 4 and the negative 5i goes together. So our final answer is negative 12 minus I. Now in this case, it's pretty much the same as rationalizing, because remember, I is a square root of negative 1. And in terms of simplifying a fraction, we always want to rationalize, meaning we don't want to have a square root in a denominator. So the strategy is the same. We're going to go ahead and take this and try to get rid of that I, and because it's a binomial, we want to use the concept of conjugates. So I'm going to go ahead and multiply this by 2 minus I. And again, in this one, we're going to have to FOIL the top and FOIL the bottom, just like the other problem that we did. So again, 6 times 2 is 12. Then 6 times negative I is negative 6I. Then we have 4I times 2, which is positive 8I. And then we'll take the last one, which gives me negative 4I squared. On the bottom, we do the same. So again, 2 times 2 is 4. 2 times negative I is negative 2I. And then 2I, and we get negative I squared. But again, we don't like to have these I squared, so we have to simplify those. So if we do that, then we pretty much just replace the I squared with a negative 1. Likewise, we do to the bottom side. And all this is basically just simplifying, just like we did a couple examples ago by combining like terms on the numerator and the denominator. So we get something that looks like this. And if you notice on the bottom, the reason why we do this is to cancel out the i's, which it does. So we get, after all the simplifying, 16 plus 2i equal to 5. Now because the 16 and the 2 and the 5 do not have any common factors, this would be your final answer. But because they're asking for standard form, normally we like to separate the real part and the imaginary part. So 16 over 5 plus 2 over 5i would be your final answer. So when it comes to solving, knowing how to deal with simplifying imaginary numbers come in pretty handy. But again, if I notice this particular problem, if they're asking us to solve, and again it's off of your worksheet, we want to isolate the x squared. So we want to get this by itself. So the first thing I do for this problem is subtract 11 from both sides. So you get x squared equals 2, negative 8. We square root both sides, so we get x squared equals 2, plus or minus square root of negative 8. But remember, we have to come to a point where we're simplifying, just like we did in the beginning of this section. So because there's an I inside the square root, this will become an I, so plus or minus I square root of 8. But again, we all know that square root of 8 does have a perfect squared factor of 4. So if we rewrite it this way, we can then change the 4 into a 2. And normally we like to put that number in front of the I, and then leave the square root of 2 inside. And that would be your answer for this problem. Here's another problem. Pretty much the same idea. We want to isolate the I square. So at this point, you can go ahead and try this on your own, and then resume it. See if you can do it by yourself. So if we do, the first thing is to add 8 to both sides. We get negative 28. When we square root it, we get plus or minus square root of negative 28. But we want to pull out that negative, so it'll become plus or minus I square root of 28. We know that 28 has a factor of 4. And if we go ahead and square root the 4, then it'll become I 2I square root of 7. So for this one, the idea is still the same. I still want to isolate this x, so we're going to go ahead and get rid of the 3 and the negative 7. So again, I'll add 7 to both sides. Then from here, I'll go ahead and divide both sides by 3. From here again, I'm going to square root both sides. And this looks pretty familiar as example number 5a. Again, we want to pull out the negative here as an I, but I have to make sure that 8 is already simplified, but it's not. So my final answer for this one is plus or minus 2I square root of 2. Okay, so here's another example of actually rationalizing and leaving it in standard form. So again, the idea is pretty much the same. We want to go ahead and use conjugates here, so I'm going to go ahead and multiply the top and the bottom by 5 plus I. We're going to go ahead and use FOIL here, so we get this particular sequence here. And again, I notice that there's I squared. We want to go ahead and simplify that by changing those to negative 1. And then from here, we're just going to go ahead and combine and simplify terms on the numerator and denominator. So you get something that looks like this. And again, notice how the two middle terms crosses out. And if we simplify, then we have something that looks like this, 11 plus 23i over 26. Because the 11 and the 23 and the 26 do not have any factors in common, then this would be your answer. But again, if they're asking for standard form, normally we like to pull out the real part of the number and the imaginary part of the number, so we just put it underneath its own denominator, and this will be your final answer.